Let's look at one more example of applications of right triangles. In this diagram, we are given a large triangle BCD, and inside that triangle is another right triangle BCA. And we want to solve for missing sides of CA and BC. The best thing to do here is to actually break this big diagram into two triangles and institute the trig functions and see how we can solve for these missing sides. So let's start out with a small triangle, BCA. And here, my missing side is H and X, and I have an acute angle which is 42.3 degrees. And with all trig functions, I need to identify the parts of the triangle based on the angle given. So here, this is my acute angle. CA, which is X, is going to be my adjacent leg because it helps form that acute angle. And H is opposite leg to that acute angle. Now, a trig ratio that deals with opposite leg and adjacent leg is tangent. So I create my formula, tangent of 42.3 degrees equals H over X. So we can actually solve this problem for H, and here we have H equal to, multiplying both sides by X, would give me X tan of 42.3 degrees. Now let's take a look at the larger triangle. Here, BCD, and again, BC is still H, but here CD is the entire segment including A. So this is X plus 75. And my acute angle here is 25.4 degrees. Again, using trig ratios, I want to identify the parts of my triangle based on this acute angle. H is going to be my opposite leg, and X plus 75 is my adjacent leg. Again, I'm going to use tangent, opposite over adjacent. Tangent of 25.4 degrees equals opposite, which is H, over adjacent, which is X plus 75. I can solve for H, and when I do, I get, multiplying both sides by X plus 75, I get X plus 75 times tangent of 25.4 degrees. I copied the equations from the previous slide here for more room. As you can see, that each expression is equal to H. When that occurs, I can actually create an equation where the expressions are equal to each other since they're both equal to H. Now that I have the expressions equal to each other in an equation, I can solve for X by getting all my X variables on one side and all my trig ratios on the other side. Let's do this by dividing by X plus 75 and tangent of 42.3 on both sides of the equation. When that happens, I'm going to end up with the left side being X over X plus 75, and the right side of my equation being tan of 25.4 over tan of 42.3. Now what I can do is substitute this expression into a calculator. I've already substituted into the calculator, and I'm going to get 0.5218. And we can set our expression equal to that. Now, I can continue solving this problem by multiplying both sides by X plus 75. That's going to give me X equal to 0.5218 times X plus 75. And when I distribute, X equals 0.5218X plus, and then I'm going to use a calculator to solve for 0.5218 times 75. I'm going to get 39.135. Now I can continue solving this problem by subtracting 0.5218 on both sides. And when I do that, I'm going to get, on the left side, 0.4782x equal to 39.135. Now, I'm going to divide both sides by 0.4782. And when I substitute 39.135 divided by 0.4782 into the calculator, I'm going to get approximately 81.8381. To complete the problem, all I need to do is take my value for x and substitute it into one of my original equations. This is the easiest one. That would give me tangent of 42.3 equals h over 39.135. Solving for h, I get 39.135 tangent of 42.3. Then I can substitute into the calculator. I've done that already, and my solution would be 35.610.